Today we are going to understand two terms that sound similar but solve two different problems: authentication and authorization. These concepts are used in almost every real application. Whenever you log into Gmail, Instagram, an online course platform, a banking application, or your company dashboard, authentication and authorization are working behind the scenes. The easiest way to understand the difference is through two questions. Authentication asks, who are you? Authorization asks, what are you allowed to do? Let us understand this using a simple course platform. Our platform has three types of users. So let me open a sketchpad. Our platform has three types of users: the student, instructor, and admin. A student can view courses and access the courses in which they are enrolled. An instructor can create and update their courses. An admin can manage all users' courses and inquiries. Before deciding what a person can do, the application must first identify that person. The identification process is called authentication. Authentication means verifying the identity of a user. Suppose a user enters email as student@example.com and password as something like secret123. The server checks whether this email exists and whether the password is correct. When the information is correct, the server says, yes, this user is student@example.com. That is authentication. The application has answered the question, who are you? So authentication is who are you? First is authentication, that tells who are you. And second is authorization, that tells what are you allowed to do. So authentication commonly happens using email and password, phone number and OTP, Google login, GitHub login, fingerprint, face recognition, security key. The method may change, but the purpose remains the same. Verify the user's identity. Imagine that you are entering an office building. At the entrance, the security guard asks for your identity card. You show the card and the guard verifies your identity. At this point, the guard only knows who you are. The guard has not yet decided which rooms you can enter. Identity verification is authentication. Now, after a successful login, the server generally creates something that helps identify the user during future requests. This could be session, a session cookie, a JSON web token commonly called JWT, a token created by an authentication provider. Conceptually, the server gives the user a digital identity card. That identity card can contain information such as this. So, a digital identity card is given by the server and it looks like this. Now, whenever the user requests protected information, the application checks this identity. The browser might send a token like this, like authorization bearer user token. So the browser sends token like this. The server validates the token and identifies the user. Do not worry about implementing tokens today. We will cover the login flow separately. For now, remember, authentication proves identity. Authorization means deciding what an authenticated user is allowed to access or modify. Suppose our application has already authenticated this user, the user that has pasted. We know who the user is. The next question is, can this student create a new course? The answer is no. Can this student view an enrolled course? The answer is yes. Can this student delete another user? The answer is no. These decisions are part of authorization. Authorization answers what are you allowed to do. Authorization answers what are you allowed to do. Return to our office building example. The security guard has verified your identity card. You are authenticated. However, your identity card may only provide access to the reception, your department, the cafeteria. It may not provide access to the server room, the finance department, the director's office. The system knows who you are, but your access is limited. That access decision is authorization. Let us compare both concepts clearly. Authentication asks, who are you? Examples include logging in using email and password, signing in with Google, verifying an OTP, validating a session or token, and authorization asks, what are you allowed to do? Examples include, can this user open the admin dashboard? Can this student view this course? Can this instructor edit this course? Can this user delete this inquiry? Authentication normally happens first. Authorization happens after authentication. You cannot reliably decide what someone is allowed to do until you know who that person is. So suppose our database contains the following users. So Aman is a student, Priya is an instructor, Rahul is an administrator. Now imagine that all three users try to access different routes. A public route can be accessed without logging in. For example, get/courses. Anyone can view the public course list. Conceptually, so here you can see the public routes. app.get/courses. This is a public route. Anyone can access this. There is no authentication check. Now consider this route/my courses. Only logged in users should be able to access it. A guest should not be able to see someone else enrolled courses. So here authenticate user checks whether the request belongs to a valid user. If the user is authenticated, the middleware adds the user information to the request. So here is the middleware. Once it is authenticated, then it adds request.user is equal to user and user equals user's token. And we are getting user's token from here. If it is student token, then we get student token as instructor token or admin token. So if the user is authenticated, the middleware adds the user information to the request. The request then continues to the route. Now let us see how this middleware works. So let's go to function authenticate user. So let us understand the flow. First, we read the authorization information from the request by this line. If no token exists, we return a 401 response. If the token is valid, we identify the user. So we identify the user by this line. We then attach that user to the request by this line. Finally, we call next. Calling next means that the request is allowed to continue to the next middleware or route handler. This middleware performs authentication. It answers who is making this request. Now suppose only administrators should access this route. Get/admin/users. Checking whether the user is logged in is not sufficient. A student might also be logged in. We must check the user's role. Let us create an authentication middleware. So here we have created it. Sorry, authorization middleware. So it checks if the person is admin or not, and then we protect the route like this by adding authorized admin. Notice the order. First, authenticate user, and the application checks who the user is. Then allow roles admin or authorize admin. The application checks whether that user is allowed to access the route. Finally, the route handler runs. The complete conceptual flow looks like this. So user sends request. Is the user logged in? No. So return 401, please log in. If yes, identify the user. Does the user have the required role? No. Then return 403, permission denied. If yes, it run the protected route. This is the basic protected route concept used by many applications. The exact code changes depending on the framework. The exact code changes depending on the framework, but the flow remains almost the same. Let us imagine the student accesses. So let us run this. So it is running at HTTP localhost 3000. Okay, it's not working. The server runs and then closes. So maybe we need to fix this. So I will be using AI agent while the server crashing. So it is trying to start the server. The server started successfully and ran for some time. What it is asking is inspect PID. So I will allow this. So server port 3000 is being held by cursor itself. The server started successfully and ran for roughly 7 seconds before exiting with clean code. Port 3000 is still occupied. The shell may take two time. Tool may have timed out. That is the process. Okay, something is already running on port 3000, or maybe it is saying that use a free port 3001 to stop or stop whatever is on 3000. So I will go for port number 3001 instead of 3000 because that is simpler. And this also needs to be changed. Now let us open the simple browser and open localhost 3001. I need to go to courses. Okay, so I'm getting it. Now let us open install this Echo API. Once you install this, then you can open it from here. And I click on HTTP request. Now first we will make request to get slash admin slash users. Let us imagine Aman the student accesses slash admin slash users. Let's go back to Sketchpad. Aman makes a request. Aman is a student. If Aman is logged in, so authentication succeeds. The server identifies him as ID1. So let's try to make the request from the extension Echo API. So I'm getting the courses because that is public route. And if I put my courses, then I should get 401 error. Please log in to continue. Now let me make some change. I will send one header with the bearer authorization token as authorization as bearer, and I will open the users student token. Now I am logged in as if I send like this, the server will identify me as student Aman. So I should be able to see my courses. Right. Now let us try to access the slash admin slash courses slash admin slash users. Now this route can be accessed by only the admin, and we know that Aman is not an admin, so he will get authorization error 403. So Aman's role is student, not admin. Therefore, authorization fails. The server returns you do not have permission to perform this action, and the response status is 403 forbidden. Now Rahul accesses the same route. So Rahul is uh, Let's open the users. And Rahul is admin. So let me change this to new token, admin token. And if I go to my courses, then he should be able to see the courses. Now I try with the /admin slash users. Then he should be able to see because Rahul is an admin. Authentication succeeds, authorization also succeeds because Rahul has the admin role. The server returns the user list. A route may sometimes be available to more than one role. For example, instructors and administrators might both be allowed to create courses. For example, if you see in this server, then both instructor and admin are allowed to create the course. A student will receive a 403 response. An instructor will be allowed, and an administrator will also be allowed. This approach is commonly called role-based access control or RBAC. Each user is assigned a role. For example, student, instructor, admin. Each role receives certain permissions. So these are the permissions I will show you in the sketchpad. This is role-based access control. Instead of checking individual users everywhere, we check their roles and permissions. This keeps the application easier to manage. Ownership-based authorization. So roles are not always enough. Suppose Priya is an instructor and has created course 101. Another instructor, Ravi, has created 10, course 102. Both users have the role instructor. Should Priya be able to edit Ravi's course? Usually no. Therefore, we must also check ownership. Conceptually, I can show you one example. So let's add this route. App.put, and here we have authenticate, and here we have authorize. So instructor and admin can access this route. Here authorization depends on both the user's role and whether the user owns the resource or not. This is common in real applications. So here you can see we find the course and then we check if the person is owner of the course or not. If he is the owner, then only he can edit the course. If not, then he cannot. This is common in real applications. You may edit your own post but not another person's post. You may view your own order but not another customer's order. You may update your own profile but not another user's profile. Beginners often confuse these two status codes. 401 unauthorized despite its name. 401 usually means that authentication is missing or invalid. Although it says unauthorized, but it means authentication is missing. The application does not know who the user is. So examples are no token was provided or the login session expired, the token is invalid, the user has not logged in. In all these cases, we get the response 401 unauthorized. A simple way to remember it is 401 equal to I do not know who you are. So we can write this. Now a 403 response means that the application knows who the user is, but the user does not have permission. For example, a student tries to open the admin dashboard. An instructor tries to delete another instructor's course. A normal user tries to manage other user. In all these cases, we get responses 403 forbidden. So remember that 403 equals I know who you are, but you cannot do this. The frontend can also hide or redirect protected pages. So uh, this improves the user experience. However, frontend protection is alone is not secure. A technical user can manually call the backend API using Postman, Thunder client, a browser console, or another script. Therefore, the backend must always verify authentication and authorization. The frontend can hide the button, but the backend must protect the action. For example, we may hide the delete course button from students, but the backend must still check that allow roles is admin. Never trust only the frontend for security. Now let's discuss the common mistakes. First is treating login as permission. A logged in user should not automatically get access to every route. Authentication does not mean unlimited access. Always ask, is this user allowed to perform this particular action? Second mistake is protecting only the front end. Hiding a page or button does not secure the backend. Someone can directly call the API, so always enforce authorization on the server. Third mistake is trusting a role sent by the browser. Never accept something like this for verification, like role admin if browser is sending. Don't trust this. A user can modify front-end data or API requests. The trusted role should come from a validated session, token, or database record. Fourth mistake is returning the same response for every failure. Use the correct distinction. Not logged in means 401. Logged in but not permitted means 403. This makes the API easier to understand and debug. Fifth mistake is checking only roles and ignoring ownership. Two users might have the same role, but should not necessarily access each other's data. Checking whether the resource belongs to the requested user. So we need to check roles and ownership also. So let's recap. Authentication answers who are you. Authorization answers who are what are you allowed to do. Authentication verifies identity. Authorization verifies permission. A public route requires neither. A public route does not require either authentication or authorization. An authenticated route requires a valid user. A role protected route requires both a valid user and the required permission. And remember the status codes 401 means you must log in, and 403 means you are logged in but you cannot perform this action. And most importantly, never rely only on the front end to protect sensitive data or actions. The backend must always verify the user's identity and permissions. Now, task for today. Create a conceptual access control plan for a course platform with these three roles. Student, instructor, and admin. So you can copy from this GitHub this code. I will upload it to GitHub after this demo ends. Then define whether each role can do these things, like view course, enroll in a course, create course, edit course, delete course, view all courses. Then write pseudocode for these three routes, or simply write the code. Why to write pseudocode? Write the JavaScript code for these three routes. For each route, decide whether the authentication is required, which roles are allowed, whether ownership must also be checked, whether failure should return 401 or 403.